we are looking at, we're going to look at finance, and we talked about writing recursion relations. So that's using all that language of, the initial VO and the N+1 rule to find the next term. So now we're going to slowly go through all the different combinations of the recurrence relations with the finance theme. So the first one we're going to look at when we're modelling linear growth. So linear growth is an arithmetic sequence. So, sorry, I think I spelled that wrong. Sequence. And so remember where you're adding and because it's growth, it's going to be adding the same amount each time. So a model of this, or like a practical application of this, is going to be simple interest. So what we're going to look at, we're going to be looking at today the growth one. So growth is when you're adding the same amount. So that same amount, when we have a summary formula, you can see there, we give the letter D. So D is the same amount that you're adding on. If it was decay, which we'll do again tomorrow, you'll see it's when you're minusing this thing. But today we're going to do the simple interest, which is growth. Okay. So what you have with simple interest is a fixed amount of interest is given to over the time periods. So say, for example, if I said I invested $1,000 and I'm going to get 10% per annum simple interest. So what you say, 10% of 1,000 is $100. So what is going to happen? I'm going to keep on adding $100 every year. So see how it's the same amount? It's not changing. So it's actually the percentage of that initial amount. So it's a percentage of that $1,000. They work it out, and then that's what they're going to add every time. So that's what simple interest is, when you're adding the same. You found out a percentage and the same amount. So we're going to be asked to write a recurrence relation. We'll be given a simple interest scenario. So say this scenario that I've just written, and we'll be asked to make it into a recurrence relation. So the way I do that, what a recurrence relation means, you just write it like this. So the VO would be what I initially invested, which is 1,000. And then I write the rule of how I get the next term. So it's going to be whatever you had before plus, in this example, so this is in that example, we're adding 100. And that would be the formula. That's the recurrence. This is the recurrence relation for that scenario. So how did I work out the D? So you can see here we've got a formula. So what I did when I was working out 10%, what I actually did is 10 over 100 times the VO, which was 1,000, and that's how I found that I was adding 100 every time. Okay, so this is that's our financial modelling of a simple an arithmetic sequence. So I've just written these little terms down here so we could write a little bit of a summary of what they mean. So when you see the VN plus 1, this is going to be it's how we get the next term. It's the label, really. That's what that means. And it's used in, you're going to see the VN plus 1, that's used in the recurrence relation. So just beware when you see that we're talking about recurrence relation. So VN you will see, and that's the current value, yeah? So generally it's what your value you're trying to get at that time, or you have at that particular time. Now VO is the initial value. Now we're going to see in finance, often the initial value is known as the principal. So when they talk in banks and stuff, when you invest 1,000, that's your principal. What you initially start with is called your principal amount, okay? So that's the initial value. Now D is it's the amount being added, okay, or subtracted if it's decay, we'll see. And it's, you know, you've calculated it from maybe a percentage. A percentage rate, okay? And now R is often indicates our percentage rate per annum. What does per annum mean? Yeah, it means per year, or, you know, so the yearly rate. So sometimes you might see, they might say percentage P dot A. That means per annum. They're quoting that, per annum. Okay, so here we're going to look at an example question. So Cheryl invests $5,000 in an investment account that pays 4.8% per annum simple interest. So what we need to get really good at is we have to highlight in our questions what we're talking about. So we're talking about simple interest, so that, you know, make sure you're using the right formulas. Obviously, when we're doing in the textbook does a whole heap of just simple interest questions, so you're not deferring around. In the exam, it's all going to be mixed up, okay? But they will state what you're using, so you'll know that you're using simple interest because they'll say it. So highlight it and know that that's the formulas you need to use. And when you also go through, so when you say Cheryl invests $5,000, I like to put VO above it, so then it'll help me. I know that's what that is. And then I see the 4.8% per annum, I'm going to put the little R because that's what we normally indicate. Now, they've been nice with this question. They said model this simple interest using the recurrence relation. So they've actually written out how you can model that. So this was like in our notes before. But in what happens is in the exam, they won't have that there to help us. So what you'll do is that you will go, all right, I'm using simple interest, and you'll probably be using your formula summary sheet. So I'm just going to show you, and I'm going to grab that and show you how you can use that to help you when it's all mixed up. So I've gone and grabbed it from our summary sheet to show. So if this is here, they've put it here nicely in the question. In the exams, you're not going to have it. All you're going to be told is that it's simple interest. So what I want you to do is you go to your simple interest section of your formula sheet. So I've grabbed that part there. Now you can see that this column here is when you need to write a recurrence relation on simple interest. So can you see that is pretty much what's listed out there? Yeah? So you'll be able to find that. Just we'll learn a little bit later, just in the next examples, we're going to see that we need to find the nth rule. When we do the nth rule, that's in this column of your simple interest, okay? And then there's just a few little notes to help you with some stuff, okay? So let's go do this question now. We've got, so they want me to model a recurrence relation. So with a recurrence relation, we have to state the VO. So what was her initial investment? It was $5,000. And then we have to write the rule, the VN plus 1 rule. So you can see on my formula sheet, see how VN is in black? That means I don't need to change that. That will just be written like that. And you can see I have to plus, and then I have to write what the scenario's D value is. Now, we don't know what the D is. We'll have to work it out. So if I do that over here, so the formula for D is R over 100 times VO. So in this example, it's 4.8 over 100 times 5,000, because that's what VO is. And if we do that, so we get that to be 240. So back up here, that's what I'm put in here. And this is my answer for the recurrence relation, okay? You have to have both of those things stated. And this is how I found the D value, okay? Let's go and do another one. All right, so here's another one. So they said Cheryl's simple interest investment is modelled by this. So this is what they've written here. They've given you the recurrence relation. That's a recurrence relation. Because it's got the N plus 1 rule and the VO, that's what you call a recurrence relation. Okay, and where they say they'll tell you what the formula indicates where they're saying that N is years. So every year she's getting a certain amount added to it. So let's have a look at the first question. It says, use this model to determine Cheryl's investment after 3 years. Okay, so what they want you to do, normally you have to show the working out how you get it. So we've got VO. If I was going to get V1, it will be the VO 5,000 plus 240, which equals 5,240. Then you have to show that V2 is the 5240. So we're constantly adding the 240, and then you get to the V3 and you'd show that it's okay, so we've shown that it's 5720, and you need to show the working out. If you're doing it, so we saw yesterday, if we're doing it on our calculator and you just want to set it up, you know, you just would type in the 5,000, press enter, and then here when you go answer, when you say add 240, that's what it'll do, and then you can just keep pressing enter and you'll start to get all these things. So if you do it on your calculator, we can see this is 1 year, 2 years, 3 years. So here you've used the model to show that V3 is that much. Then question B, when will Cheryl's investment first exceed 6,000? So what we probably want to do is just keep clicking enter on our calculator until we get to 6,000. So if we kept going, you're going to see 5,960, and then we get, finally we crack the 6,000. So this was 4, 5. So when will Cheryl's investment first exceed 6,000, and and what will its value be? So we're going to say, see, it was 5. So it exceeds 6,000 after 5 years. After 5 years, and is 6,200. There you go. Okay, so when we're looking at the nth term in a sequence, so we saw before, when we have the recurrence relation, we are just finding the next term using the one before. So, you know, we could keep pressing enter on our calculator forever. But what if we want to know what happens after, 30 years? We don't want to sit there starting at the start and go through the 30 years. So what we do is we convert it to the nth term formula. And so here's the basic one for simple interest. This is the nth term formula. Okay, so what we'll notice is this is the way I can find any term, or like in the scenario, in the sequence. So Vn is the value of investments after n periods. VO is still our initial amount. And we see D is still found the same way, where we are finding that percentage of the initial amount. So what they've done here, they've just written, if you look down here, they've just written this formula out again, where they've swapped the D for the actually how you find D, yeah? So you could use either way. So if you haven't worked it all out, you can use either formula. So, and we're just remembering here that an arithmetic sequence, which is simple interest. So we've got simple interest here is going to look like this on the graph, where it's going to grow up by the same amount each time. So that means we've got a straight line. So maybe just double check, write that again, that it's a straight line. Okay, so, oh my God, I can't spell. Yeah. All right, let's go through this. We've got this little example over here. So it said Annie invested 3,000, so VO, in simple interest. So I know I'm finding the nth term formula, and it's paying a rate of 6.5% per annum. Now, it says it says use the rule to find the value of up to 10 years. So we want to use the VN rule. So the VN rule, I'll write it out here, is VO plus N times D. Okay, if I'm just on the side, I'm going to work out what D is, which is the rate over 100 times VO. So that will be 6.5 over 100 times the 3,000. And what does that ends up being? 195. Okay, so if I go to write the nth term formula, it's going to be 3,000 plus 195 times n. Can you see, I don't like to put the n in the front. We like to actually put the letter after the number. So that's why. So this, I've just made an nth term formula. Okay, so now they want us to find 10, so that would be V10. So in my formula, every time I see an n, I put a 10, which is there. And then if we work that out, we end up with 4,950. So V10 here. So there's my final answer. Okay, so the following recurrence relation can be used to model simple interest. So, yep, it's a recurrence relation because we've got this rule and we've got the VO, and it's simple interest because we're adding that same amount every time. Okay, where VN is the value of the investment after N years. And it says, what is, so we've got to go through a few of these questions. Okay, what is the principal of the investment? So looking at that scenario, this up here, what was initially invested? You should be able to see that. What was the principal?
3,000.
Good. So we can see that's VO, so we can just write it was 3,000. And how much is added every year? Well, how much interest is added every year? So what's the interest added every year? Looking up at that formula. 260. Good. So it's seeing if we can understand what that formula is telling us. Okay, write down the rule value for the after n years. So this is where we need to use the nth term formula. Okay, so we needed to they want to write the rule for the nth term. So this is pretty much they want the nth term rule. So let's go grab the formula. Okay, so we need to get the nth term formula. So that's the middle column down here. So I'm going to be using this here to write the nth term. So I can see here I've got to write Vn equals, now I've got to put the VO, so in this case is 3,000, and then I've got to go plus n times d. So in this case, d is 260, so I go n. So there's the nth term formula. Then it says in question C, use the rule to find the value of, after 15 years. So that would be V15. So I means I pop into the formula where I see n, I'm going to put times 15 and get, what do we get? Whoops. Okay, so we get 6,900 is V15. And then the last question saying, use the rule to find when the value of the investment equals 10,000. So this is a case where you let the nth term, you want that value to be 10,000. So what I'm saying is, that 10,000 equals the nth term, which I know is this, 3,000 plus 260 n, and n's my question. So I'm just going to pop solve in here and comma n, and that's going to tell me at what time does it thing. And we end up with n equaling 26.9. And we could say 26.9 years. If they say in what year round it, you'd have to go up, because you always have to go up, because if you're in the, just say 26, you haven't made it there yet, so you'd have to say 27. They're not very clear here, so just maybe leave it as a decimal like that, 26.9 years.